Very good evening, all of you. Welcome once again. Very good evening, all of you. So, guys, in this particular session, we are going to do some questions, do some practice on organic reagents and name reactions. ठीक है, तो मैंने आपको ये पहले ही बता दिया था. आई होप कि आपने रिवीजन कर लिया है थोड़ा बहुत. यस. Good evening, very good evening, Dhanya, Jeet, Shubhadeep. Welcome all of you. Very good evening. So yes, we are going to start our discussion. चलो practice से ही शुरू करते हैं. Disha, good evening. Everyone, good evening, guys. All right. So there are some topics जो कि let's say for example spectroscopy जो कि काफी scoring topic है. ठीक है. We will also be doing questions on those topic. Spectroscopy हो गया और let's say inorganic chemistry हो गया. So we will be doing those things. But उससे पहले क्योंकि live session I think live session are more useful than video recording. So we will be doing some live, concept classes before we directly do the practice. क्योंकि reaction mechanism, intermediate, name reaction, इन सब चीजों की चैनल के ऊपर काफी सारा कंटेंट है ऑलरेडी, इसलिए मैं यहाँ पे सिर्फ प्रैक्टिस करवा रही हूँ इन टॉपिक्स के लिए. लेकिन जो नए टॉपिक्स है जैसे लेट्स से स्पेक्ट्रोस्कोपी है, उसका कंटेंट मैंने अभी बनाया नहीं है, तो इसलिए हम लाइव क्लास कर लेंगे ताकि टॉपिक का डिस्कशन भी हो जाए. एंड इन द लास्ट फ्यू डेज आप एकदम शॉर्ट में उस टॉपिक को समझ पाओ एंड देन वी आर गोइंग टू मूव ऑनवर्ड्स टू प्रैक्टिस. ओके. Yes, Dhanya, I will be using both the languages. Okay, so yeah, as I said, that for basic stuff, that is reaction mechanism, intermediates, name reaction, organic reagents, a little bit of content is already there on this channel. So you can just revise from that and directly come to practice. For spectroscopy, I will be, let's say, doing more live classes, concept classes, and then we jump on to practice. So ये मेरा target है for the upcoming CSI net examination, that all of the organic chemistry we are going to consider in live classes only, because I think कि live classes are more useful for all of you because you can interact. So in the live class only we are going to discuss all these things. ठीक है? Where should you start for JAM? Actually, for IIT JAM preparation also, I have planned something, but it is going to take some time. See, what I can advise you is, first of all, look at the previous year questions of IIT JAM. Okay. And whenever you want to prepare for any examination, first of all, just look at the previous year questions. If possible, if you are getting some topic wise assignment anywhere, okay, because topic wise question solving will give you more clarity that which topic, what questions are being asked. So get topic wise PYQs. You are going to get this a lot on Telegram. Telegram के कोई भी chemistry channel पे you are going to get all of these things, right? So when you see the question, then you will be able to sort out how to start the preparation, what to do, okay, and start from easy topics. You will be able to cover them faster. ठीक है? Yes, guys. Okay, so for the CSR net examination, आपका एग्जाम अभी 26, 27, 28 दिसंबर को हो रहा है. So we have some time, guys. Let's say we have around 50 days. So we will also have a strategy discussion for the next 50 days. लेकिन अभी हम अपना practice continue कर लेते हैं. We will also discuss how to use the time at in the best possible way. Okay, chalo. Yes, let's start the discussion. Correct order of the reactions involved in the following transformation is. Okay, try this out, guys. ये काफी अच्छा question है. Alright, first step में alpha beta unsaturated carbonyl and acid is present at minus 78 degrees centigrade. Yes, half of you have answered already. Done. See what can be done in the first step. In the first step we have acid, so we are going to maybe form an enol from where in this molecule, and we might do a Michael addition क्योंकि Michael addition ही तो possible है ना अल्फा बीटा unsaturated carbonyl पे. तो let's try. यहाँ से एक proton remove करते हैं because this is a more acidic proton. So let's say, alright, let's say we have formed the enol directly. ये हो गया OH. Alright, what is next? Next we have this molecule alpha beta unsaturated carbonyl. So in the presence of acid, it is going to be attacked from here. So the first reaction being Michael addition reaction. Option number 1 or 3 could be correct. 2 और 4 को हम पहले ही cancel कर देते हैं. We will cancel 2 and 4. Does not make sense. So how is it going to be? It will get the ketone back. Alpha halo ketone मिल जाएगा वापस से. CO2Me as it is, right? And this side is going to be your ketone back again. Okay, what happens next? In the next step, this is Michael addition. Next step में क्या है हमारे पास में? Next step में हमारे पास एक base है. Okay, what is this base? CH2 minus, right? Or let's say we have 1, 2, 3, 4, 5. We have 1,5 dicarbonyl, guys. 1,5 dicarbonyl whenever you have, do we have a aldol reaction possibility? पहले क्या होगा? Quasi favors की पहले होगा या aldol पहले होगा? See, in the presence of acid, you still have the possibility of aldol, right? So who is going to enolize? Let's say यहाँ पे भी एक प्रोटॉन है और यहाँ पे भी प्रोटॉन है. Let's say इसको enolize करके देखते हैं, for example. ठीक है, let's try to enolize this one. Then we will do a aldol reaction over here. If this carbon is going to attack over this carbon, it is going to give you a tricyclic compound which is going to be strained. So what we'll do, rather यहाँ से प्रोटॉन निकाल लेते हैं. Let's say CH2 minus. Let's try doing this. 1, 2, 3, 4, 5, 6. If we are removing a proton from here, we are going to get a 6-membered ring. Product में हमारे पास 6-membered ring है नहीं. So what are we going to do? चलो ठीक है, let's try to draw this because anyways we are going to try one more reaction. Quasi favors की ये हो गया ऐसे. All right, so this is your carbonyl. This is the OH. There's going to be a double bond over here, but you are getting a 6-membered ring on this side. Now we could have tried a quasi favors की, लेकिन ये जो carbonyl है, this carbonyl is lost over here. So how are we going to do the third one? Quasi favors की rearrangement. Yeah, we need a carbonyl over here for this reaction to happen. Okay, एक काम करते हैं, let's leave this because I need a bigger space to write this. कभी कभार ऐसा हो जाता है कि क्वेश्चन ही मैं इतना बड़ा ले लेती हूँ कि मेरे को आंसर लिखने की जगह नहीं मिलती है. The answer is option number 3 for this. I'll arrange some extra space for this question to be written. Let's move onwards to the next one first. ठीक है, ये वाला करते हैं पहले. major product A and B in the following reaction sequence. Alright guys, let's first do this question. We'll do this question in the next session. I'll take it smaller. ठीक है, चलो. Good evening, Sabuj. Welcome. Alright, this is also a name reaction. I made you do this long time ago. नहीं तो देखते ही हो जाना चाहिए. Yes, everyone has to answer, guys. All right. Anybody, do you remember the name of this reaction? Yes. What are we doing over here? H2O2 NaOH. And again, we have to consider dynamic stereochemistry over here. Dekho, this methyl is present above. The alkene is planar. Where is the epoxidation going to take place? All right. So this epoxidation is not a concerted mechanism, isn't it? क्योंकि ये peroxide anion है इसीलिए. So this is not a concerted mechanism. The epoxidation will take place from below the plane. Okay. So it is going to be like this. Yes. So all right. This is how the epoxidation will take place, not from above. Okay, we have already considered this possibility that why this is happening in the dynamic stereochemistry session. Okay, if anybody has any trouble, you can see from there. Now, what happens in the next reaction? Hydrazine क्या करता है? Wolff-Kishner reduction करता है, but this is not simple Wolff-Kishner reduction. As soon as you are forming the hydrazone, and there is a possibility of the epoxide opening also. Why? Because the acetate can remove this proton from here and release this epoxide bond. ये बन जाएगा OH, ये आ गया डबल बॉन्ड इधर पे, मिथाइल मिसिंग, right, and double bond NH. Okay, this bond can fall over here. All right, it is not a rearrangement, it's a simple elimination of nitrogen molecule. So there is a similar reaction to Wolff-Kishner. What is that? उसका भी कोई नाम है? Warton rearrangement. All right, Warton reaction very similar to Wolff-Kishner. So alpha beta epoxy ketone को reduce कर रहे हैं. So you are not actually getting a alkane as you would have got in the Wolff-Kishner reduction. You are getting the allylic alcohol. All right. Yes. Acetic acid का use क्या है? Acetic acid is there to open up this epoxide. All right. The epoxide will open. It will give you the alcohol, and the remaining acetate is going to pull out the proton. देखो usually जब acid present होता है तो हम उसको as a base नहीं लिखते हैं. So we don't write it like ACO minus. We are going to write it as ACOH, and the excess of proton is taken away by the epoxide. You can write it like that. Okay. Epoxide opening will take place both in the basic as well as acidic medium. यहाँ पे medium थोड़ा सा acidic है. Okay, not like Wolff-Kishner. चलो, another very important and repeated reaction, major product formed in the following reaction is, see, what do you have? Again, alpha beta unsaturated carbonyl. This question also appeared in your GATE examination. और ये CSR नेट में 2 बार आ चुका है, 3 बार आ चुका है बेसिकली ये in the previous years, twice in CSR net and once in GATE. Yeah, what is happening over here? Yes, guys, कहाँ से उठाया ये question? Anybody studying the books can tell. किसने किताबें पढ़ी है बताओ? CSR नेट गेट बीच बीच में किताबों से क्वेश्चन पूछ लेते ताकि स्टूडेंट्स का विश्वास किताबों पे बना रहे. 3 is it? Yes. Dipanshu, Shubhadeep, Shabuj, Bhavdharni, everyone, very good. From Caruthers, yes. So basically, this carbonyl and a tosyl hydrazine, whenever you see, you're always going to first make the tosyl hydrazone. That's simple. सबसे पहले क्या करेंगे? हाइड्राजोन बनाएंगे. The hydrazone looks like this, isn't it? Carbonyl and hydrazine is going to give you the hydrazone. Second जो reaction है, that is sodium cyanoborohydride we are using. What is this used for? Sodium cyanoborohydride. This is a chemoselective reducing agent used only for the reduction of the imine bond. अब ये imine bond usually ऐसा लिखा जाता है at pH is equals to 5 to 6, but it is not mentioned. When it is not mentioned, then also we will understand that it is chemoselectively going to reduce this bond. So H minus specifically for this carbon. अब ये अगर H minus ट्रांसफर करेगा तो टोसाइल को जाना पड़ेगा यहाँ से, right? What do we have? We have N, double bond N और एक हाइड्रोजन है, ये बचा है. Yes. अब क्या करें? Next, we see 70 degree centigrade. What is happening at 70 degree centigrade? Anything special? Yes, ये देखो 1,5 हाइड्रोजन शिफ्ट ऐसे करके हाइड्रोजन शिफ्ट हो गया तो नाइट्रोजन भी निकल गया. And the double bond came over here. All right. So this is 1,5 hydrogen shift. Now the important thing is, guys, ये तीन बार आ चुका है CSI नेट में, and similar questions might also appear. Directly Caruthers से आते हैं ये, ठीक है. Sometimes your question might also ask you that I am not having cyanoborohydride, I am having sodium cyanodeuteride BD3. Let's say मैंने BD3 पूछ लिया, फिर यहाँ पे हाइड्रोजन की जगह एक ड्यूट्रियम बैठा होता इधर, isn't it? There would be a deuterium over here. Or for example, if I ask you this question, I don't have a tosyl hydrazine. I have a tosyl hydrazine like this, which is having ND2 over here. तो एक हाइड्रोजन हमारा एक ड्यूट्रियम यहाँ पे बैठा होता. So depending on the isotopic substitution, the question could be modified. I always say this because keep this in mind, it can appear. ठीक है, तो कभी आप सरप्राइज मत हो जाना अगर आइसोटोपिक सब्स्टिट्यूशन आ गया यहाँ. चलो, let's move onwards. Very nice question. Another one. Major product formed in the following reaction. Right? This is a very easy question. Too easy. Yes, exactly, Dipanshu. Mechanism will save us. If you know the proper mechanism, then only. क्योंकि कई बार ऐसा होता है कि बच्चे पहले पहले 1,5 शिफ्ट कर देते हैं और बाद में रिडक्शन करने की कोशिश करते हैं तो वो गलत हो जाता है. So first you are going to do reduction, then 1,5 hydrogen shift. So this is very important. You have to remember. Yes, very simple guys. ये तो IIT जैम वाले भी बता पाएंगे. First Reimer-Tiemann. Yes. All right. So you see the reagent. What is this? Chloroform or base? ये क्या बनाएगा? Chloroform and base. What does it form? Gives you a dichlorocarbene. So dichlorocarbene is going to react with the phenol molecule. कैसे react करेगा? And one more thing, para position is blocked. तो कहाँ से अटैक होने वाला है? Ortho position. Para position is blocked, right? So a carbene is neutral. The phenol is going to attack over carbene and it's going to basically become O minus या फिर OH positive we can write. CCl2 minus it becomes. It is going to take off this proton itself within the ring and that is going to become somewhat like this. Again the phenol comes back. तो ये process चलता रहेगा. You have CHCl2 now. The CHCl2 is going to get hydrolyzed. Reimer-Tiemann rearrangement, very simple. It is going to get hydrolyzed. CH and 2OH will be present after hydrolysis. तो ये हो जाएगा CHO. Orthoformylation. Alright, so this is orthoformylation over here. Orthoformylation में second step में we are having dakin-oxidation. Isn't it? We are having dakin-oxidation. Dakin-oxidation is very easy. क्या करेंगे? OH minus has removed a proton from the peroxide. So the peroxide is attacking over the CHO. कैसा दिखेगा ये? Dakin-oxidation में ring से कोई मतलब नहीं है. You have got to have this tetrahedral intermediate. O minus, O, OH like this. And when the bond falls back, this whole aromatic group is going to migrate. Aromatic group migrates और ये COH bond is going to form. C ऐसे करके ये बनेगा, just like Beer-Williger oxidation taking place in the presence of a base. Now the next OH minus is going to attack over this carbonyl and is going to release this catechol from here. तो second position पे OH बन जाएगा after hydrolysis. The answer is option number 1. Right? So first you are having a Reimer-Tiemann reaction, orthoformylation. Second you are having Dakin oxidation. That easy. Very simple question. आगे चले, ये तो बहुत इजी था. ये देखो, how many of you can just say the name of this reaction by looking at reagents? 2.2 equivalent of butyl lithium. बताओ, what could it be? Yes, what can you say about the reaction? Yes, guys, name reaction तभी याद रहते हैं या फिर तभी मजा आता है याद करने में कि आप रिएजेंट देखो और तुरंत बता पाओ. तभी तो अच्छा लगता है ना कि हाँ चलो, so many name reactions I remember. Which one is this? Absolutely, very good, all of you. Very, very good. Shapiro reaction. Yes, Shapiro reaction. See, what do we need in a Shapiro reaction? We need a base, we need a hydrazone and two equivalents of butyl lithium, or second step में some electrophile. We need some electrophile. नहीं जीत, ये यूजुअली जैम में नहीं आता है. ये वाला, ये थोड़ा सा हाई लेवल चला गया, जैम में नहीं आता है. ये CSI साइनाइड गेट में भी आता है. ठीक है, गेट का और जैम का यही तो डिफरेंशिएटिंग फैक्टर है. थोड़े से हायर लेवल टॉपिक्स है, बाकी गेट और जैम एकदम सेम है. पैटर्न एंड एवरीथिंग इज सेम. So this could be helpful for your GATE exam. All right, see. So 2.2 equivalents of butyl lithium, what are we doing? We are removing two protons, two acidic protons, one from here and one from here, because obviously nitrogen का proton ज़्यादा acidic है, तो इसीलिए इसको निकालेंगे minus. And then you have one more minus over here. All right. So this minus is going to push away the sulfonyl group, the sulfonate basically. There is a double bond and the nitrogen has a negative charge. Abhi nitrogen is a good leaving group. What is it going to do? It is going to push away this electron density. It's going to leave. तो electron density किस पे आ गई है? There is a negative charge on the double bond. Vinylic carbanion forms. What do you need? You desperately need a electrophile. So this is the molecule. You have dibromo 1,2-dibromoethane. क्या होगा? कार्बन पे अटैक करेगा? Is it going to attack over the carbon or is it going to attack over bromine? See, this reaction is only possible with bromine and iodine, which are more polarizable. it attacks over bromine and this Br minus pushes away. तो आपके पास जो stereochemistry है, pH is trans, this is the molecule and you are having alkene as the byproduct. 1 Br minus eliminated. Okay. So answer is option number 2 and it is our most favorite Shapiro reaction, most favorite, most repeated Shapiro reaction. Alright. चलो आगे चलते हैं. See what's happening. Major product A and B formed in the following reaction sequence. First part is very easy. Why it attacks bromine? Yes, see, because bromine is more polarizable. Whenever you have bromine and iodine and such a molecule, then the nucleophile will attack the halogen, not the carbon, because then elimination will give you entropically more favored product. Okay, alkene is eliminated, one I minus is eliminated, and this I is going with another molecule. So this is entropically more favored, right? Also favored because the electron density is flowing in one direction. That's why. Very well. All right. Can you see the reagents properly over here? थोड़ा छोटा लिखा हुआ है, but I hope that it's visible. Yes, exactly. Wittig-Horner reaction, जो कि थोड़ा सा लंबा चौड़ा है, but you know that's what it does. It give you absolutely Dipanshu, very good. See, we are having our phosphonate ester. ये क्या है basically? क्या molecule है ये? P double bond O OET like this, and then there is a CH2 COOET like this. This is the molecule, and in the presence of a base, what is the base going to do? Any H है तो H minus है. Hydride is going to take out a proton. कहाँ से निकालेगा? एक ही proton है यहाँ पे. So guys, whenever we understand the polarity of the molecules, it will be very easy to be able to answer. Just have to understand the polarity. ये बन गया CH minus. Okay. And the phosphorus is already positive because it is connected to 5 different groups. ठीक है. अच्छा, अब ये क्या करेगा? This is going to attack over this carbonyl over here. And the O minus is going to open up. So that will again give you the same Wittig reaction. जो हमारा simple एक Wittig reaction होता है, to combine a carbonyl and a phosphonium ylide to give you an alkene. The same thing is happening over here, just that we have a little bit more selectivity. It is Wittig-Horner rearrangement, a modified version. यहाँ पे E alkene बनता है, but as such in the reagent, ये देखो ये जो substrate है हमारा cyclohexanone, there is no selectivity, so fine, we are just going to get an alkene like this. 3 and 4 both are correct. ठीक है, ये कोई सब्स्टिट्यूशन तो है नहीं, सो 1 and 2 आर रॉन्ग, 3 and 4 आर करेक्ट. Now what can happen? Now in the second part, you have CH3NO2 and again a base. So ये तो डाई जो ये हमारा नाइट्रोमीथेन है, you know it will be very stable. The negative charge, if there is a base, the proton is very easily abstracted. It is very stable because of this nitro group. तो ये क्या कर सकता है? It can attack over two positions. What are the two positions? Either it can attack over the ester or it can attack over the carbonyl, over this alkene. तो हमेशा याद रखो, when the ester carbonyl is not so electron deficient. Okay, very rarely when we have alpha beta unsaturated carbonyl, when we have an ester like this, it is mostly going to face the Michael addition and not direct attack, because direct ester carbonyl attack is not possible. Ester is not so electron deficient. तो ठीक है, हम नहीं करवाएंगे एस्टर पे अटैक. हम कहाँ पे करवा देंगे? Michael addition करवा देंगे. CH2NO2 like this, and this has become the ester enolate like this. Fine. What happens next? This bond is going to go back और ये मीडियम में से एक हाइड्रोजन ले लेगा, तो ये बन जाएगा इस तरीके से. We get back our ester, not a problem. And there is CH2 and NO2. It is nitro still. Second step में नाइट्रो का रिडक्शन हो रहा है. नाइट्रो is getting reduced to amine. If that happens, this amine, if the nitro gets reduced to amine, it is now having the lone pair to attack this carbonyl. ये OET निकल जाएगा यहाँ से, right? And you are going to get a 5-membered ring. That easy. Very simple. Yes, Arjun, you're talking about Neff reaction. See, it is not Neff reaction, because Neff reaction is conversion of nitro to carbonyl. Okay, but we don't have a carbonyl. We want the amine to be able to attack over this ester carbonyl. So it is simple reduction. This is simple reduction, not the Neff reaction. Fourth is wrong, guys, because ये जो CH2 minus है, this is not going to attack over the carbonyl ester. इसीलिए CH2 यहाँ पे नहीं आएगा. Very little thing we have to take care of. This is not doing direct ester addition. It is doing Michael addition. So fourth one is wrong. Okay? Very simple question. Very simple. Third one is the correct answer. चलो आगे बढ़ते हैं. ये देखो बहुत अच्छा क्वेश्चन है. मेजर प्रोडक्ट अगेन. What is happening? Tell me. See, this is a different question on Sharpless. हमेशा Sharpless और पेन rearrangement हमेशा यही पूछते हैं. ये थोड़ा सा different है. Yes, this is from Caruthers only. See, if you cannot see, I'm telling you, ये minus DIPT है. Okay, first tell me, minus DET या minus DIPT, where is it going to give you epoxidation? Reface or psi face? कहाँ पे देगा ये? That is important, guys. Reface or psi face epoxidation, where? minus dt minus dipt will give you psi-phase epoxidation. ठीक है, so we are going to find out the re and psi phase for here, for this allylic alcohol, and only for this carbene or only for this alkene side. ठीक है, so give the priority on this carbon. This is going to be 1 over here, 2 over here, and 3 like this. So 1 2 3 is going to be anti-clockwise. तो जो टॉप फेस है वही साई फेस है. Top face is the psi face itself. So if we are doing psi facial epoxidation in the Sharpless epoxidation, we must say कि above होना चाहिए. B is going to give you epoxidation above the plane, yes or no? So either it is going to be this or it is going to be this, right? Psi facial epoxidation. ठीक है, below the plane नहीं होगा. Now we go back to metachloroperbenzoic acid. It is very simple. Metachloroperbenzoic acid gives you epoxidation of electron rich double bond. It is also stereospecific. लेकिन अब यहाँ पे ये जो ऑक्सीजन है ये एसिटल फॉर्म है. दिस एसिटल इज फॉर्म बिलो द प्लेन, राइट, एज यू कैन अंडरस्टैंड फ्रॉम दिस हाइड्रोजन, right? So it's going to form the epoxidation above. Why? Because of the stereochemistry of the molecule itself. Yes, वो substrate का structure ही ऐसा है ना, इसीलिए. So it's very simple. Answer is going to be option number 4. A is also going to get the epoxidation above. Yes, Dipansh, you have termed it correctly. ये सही है कि first में the reaction is happening above because of the substrate structure. So it is substrate controlled. And the second one, this is chiral induction basically. Chirality है यहाँ पे. So it is your reagent control, chiral reagent, Sharpless epoxidation. But both are giving you the same product. Okay. Fourth one. Very simple. Okay, आगे चलते हैं. बहुत अच्छा क्वेश्चन है. ये देखो नेक्स्ट. सीक्वेंस थ्रू विच द फॉलोइंग रिएक्शन प्रोसीड्स इज. All right. What could we do over here? All right, very well. Let's try this 3,3 Sigmatropic rearrangement. So whenever we involve the allylic vinylic system in the 3,3 Sigmatropic, then it becomes Claisen rearrangement. Yeah, we know that. So this is what we have now. All right. So what can we do about it? यहाँ पे हम क्या कर सकते हैं? ये bond हो गया है shift. All right. So we can do one more rearrangement. Isn't it? ये देखो ये जो double bond है, this is again an allylic system. We can do one more shift. Let's try to write the molecule in this way. So what do we need? We need, for cope rearrangement to happen, we need 1,5 diene. Okay, we need 1,5 diene. Also in the Claisen also you can count like this if you are confused. 1, 2, 3, 4, 5. We do have a 1,5 diene. Let's try to see what happens. लेकिन अगर हम यहाँ पे करवाते हैं, आजा कोप करवाते हैं, तो this carbon will end up over nitrogen. We don't see in the product that this ends up over nitrogen. This is not happening. Something else is happening. तो हम एक काम कर सकते हैं. We can remove a proton from here. How can we do that? अगर ये proton remove करेंगे, so the electron density is going to shift into this carbonyl. Okay, this has become double bond CH2. There was a methyl already. Okay, nitrogen will have a double bond like this with this ring in this way. ठीक है? So yes, ये क्या हो गया? This is extended tautomerism kind of. क्योंकि basically in the tautomerism step you remove a proton from here directly. ठीक है, लेकिन ये तो मिथाइल है, the position is blocked. You cannot do a proton removal from here. So ये यहाँ से proton जाएगा इस तरीके से. You get this. Now you have 1,5 diene again. ठीक है, you have 1,5 diene. You can try out 3,3 Sigmatropic once again. All carbon chain है. It is going to be cope rearrangement. And this is going to give you a molecule like this, which is going to be our product. Alright, ये अगर shift हो जाएगा इस तरीके से, so we can also write our product in this way because it is basically, the ring is all aromatic now. Okay, so this is our final product which we have got. Answer is option number 1. First Claisen rearrangement, then tautomerism from this methyl, like this proton, and then cope rearrangement. Yes, very easy. Carbon chain also getting increased, exactly. So, यहाँ से एक नया bond बन रहा है. That's why we have to be careful over here. All right, very nice question. चलो, one more question we are going to do. ये आज का हमारा last question है. Major product formed in the following reaction sequence is. The question is very simple. Again, you are, see, हाइड्रोजन और ड्यूट्रियम किसी भी क्वेश्चन में किसी भी मैकेनिज्म में डाल सकते हैं. You just need to know the mechanism and you will be very nicely able to say where the hydrogen should be or where the deuterium should be. Yes, very good, guys. Very good, Paresh, Shubhadeep. Very good, Bhava. Very good. So, first step, we are having dicyclohexyl boron hydride. Cyclohexyl groups are big. और हमें पता है कि ये जो हाइड्रोबोरेशन होने वाला है, दिस इज गोइंग टू बी सिन एडिशन. व्हाट इज सिन? The hydrogen and the boron are going to add from the same side. But which side? Isn't it obvious that there is a bulky chain over here? और ये भी bulky है, so they'll try to stay opposite. Addition will take place in this way. You're having a double bond. Bromine goes on the same side as the butyl. ये आ गया हाइड्रोजन इधर. ठीक है, कुछ भी नहीं है. लास्ट स्टेप में एक एसिड दिया हुआ है. सो whenever you have acetic acid, after hydroboration, oxidation does not take place. You're not having the alcohol anymore. You are just taking away a D plus. This system is just taking away a deuterium, nothing else. All right, so both the hydrogen and the deuterium, they are going to end up on the same side. And be careful about the butyl and the bromine कि कौन से position पे रहेगा. Deuterium will be on the same side as bromine, not the butyl group. All right, तो ये सारे ऑप्शन बहुत सिमिलर दिखने में लग रहे हैं, बट आंसर इज ऑप्शन नंबर 1. व्हाट इज द पर्पस ऑफ हीट इन द लास्ट स्टेप? ये जो बॉन्ड है, टू रिमूव दिस बोरॉन, बिकॉज कार्बन बोरॉन बॉन्ड ब्रेकिंग, it will require something more. For example, you are not providing it a base, right? You are not providing a base to this, so this bond has to be broken and the electron density has to go to deuterium. So if that happens, you are going to basically have the CD3COO minus attack over boron. अच्छा, पिछले क्वेश्चन के लिए देखो, आप बोल रहे हो शुभदीप, इफ वी डू azaclazine then tautomerism and then again azaclazine. That is, azaclazine नहीं करना है, आजाकोप होता है. पहली बात तो अगर आप बोल रहे हो कि यहाँ से अगर हम इसको टॉटोमेरिज्म नहीं करें, पहले आजाक्लेजन आजाकोप करवा दे, तो उसकी जरूरत नहीं है. ठीक है, जब हमारा सिंपल टॉटोमेरिज्म हो सकता है तो हम पहले क्यों कराएंगे? नो नो. And when nitrogen is involved within this system and you are doing a 3,3 sigmatropic, it is mostly known as a azacope. But our answer is option number 1 only. The others are just confusing you, nothing else. Okay? Alright. Yes, so here also answer is option number 1 only. Boron will leave as B positive. No, boron will never leave as B positive because it is electron deficient. बोरॉन कभी भी खुद से बी पॉजिटिव जैसे लीव नहीं कर सकता. नो, इट विल ऑलवेज नीड सम इलेक्ट्रॉन डेंसिटी, ओनली देन इट इज गोइंग टू लीव, राइट? सो मे बी द एसिटेट इज गोइंग टू अटैक over boron, only then it is going to leave. Without electron density it cannot leave. All right, so yeah, this is just another electrophile. You can give any other electrophile also. You can give a methyl, you can give any other electrophile over here and do this attachment over here. Just that there must be somebody to give borons the electrons. Okay? Yes. Now that's it guys for today, and we are going to have a similar session, similar discussion session tomorrow. See, this topic is so huge, organic reagent and name reaction. That's why we will continue the discussion of the same topic tomorrow so that we can cover maximum questions. Okay, reagents and name reactions of more recent years of CSI net exam. Right after that, we are going to move onwards to pericyclic. ठीक है, तो कल का जो सेशन होगा सैटरडे 6 PM अगेन, वहां पे हम करेंगे सेम क्वेश्चंस डिस्कशन, नेम रिएक्शन एंड रिएजेंट. उसके बाद में जो सेशन होगा वी आर गोइंग टू डू पेरिसाइक्लिक. ओके, सो या प्लीज रिवाइज एवरीवन. रिवीजन पे सब कुछ बेस करता है, सब कुछ रिवाइज करोगे तो अच्छे से आ जाएगा. ओके, yes, so that's it for today, and I hope that you are liking this series. If you are, please also share it with your friends, ताकि उनको भी ये काम आए. Yes, all right. Okay, guys, and also tell me, guys, how is your preparation going on? जिन्होंने अभी तैयारी करनी शुरू करी है, I see a lot of new students as well as my old students. So दोनों अलग अलग कैटेगरी में चल रहे हैं. Somebody has done a lot of practice, somebody has just started the practice. Definitely, guys, there will be a different strategy for all of you, but I just hope that at this particular time you practice as much as possible. Maybe easy question, maybe difficult questions, but as much practice as possible. And also don't miss out on the डिफरेंट सब्जेक्ट. लेट्स से थर्ड सब्जेक्ट, जैसे अगर किसी को ऑर्गेनिक पसंद है तो ऑर्गेनिक इनऑर्गेनिक, बट फिजिकल भी करो. किसी को फिजिकल इनऑर्गेनिक पसंद है तो ऑर्गेनिक भी करो. गाइस, थर्ड सब्जेक्ट इज वेरी इंपॉर्टेंट. ठीक है, वेरी वेरी इंपॉर्टेंट. एंड चलो, यस अंकित, थोड़ा सा टाइम लग रहा है क्योंकि अभी मेरे पास में मीन्स जो है थोड़ा लेट ही आया है क्रैश कोर्स बनाने का. थोड़ा सा टाइम और दीजिए मुझे, और बहुत ही जल्दी आएगा क्रैश कोर्स भी. ठीक है, एंड द क्रैश कोर्स इज गोइंग टू बी अ रियली शॉर्ट कोर्स विच यू कैन कंप्लीट इन लेट्स से 15 to 20 days, बिकॉज क्योंकि टाइम बहुत कम है सबके पास में, तो छोटा ही बना रही हूँ मैं. ठीक है, विच कैन गिव यू मैक्सिमम बेनिफिट इन वेरी लेस टाइम. So I am onto it, and I hope I will be able to deliver it to you within this week, let's say by the end of the week or so. All right. So guys, yes, take care of yourself, and I'll see you all in another such session. Yeah, Shubhadeep, definitely do physical chemistry. We need marks, as many as possible. That's it. और क्या चाहिए हमें? ठीक है, चलो, नॉलेज बहुत है, मार्क्स चाहिए, मार्क्स लेके आना है. All right, guys. So yes, so I will see you all in the next session. Bye everyone. Till then, have a good night.